Hey class, I wanted to give you a little video to help you guys out since I'm not here today. And I appreciate your consideration and time and thought and the fact that I need to be with my son today. You're starting the chemical math portion, and it's really not that much different than what we were doing. Now, here's the good news. Most of you totally rocked sig figs, counting them and multiplying and dividing. And that's all we're doing in this unit. We're going to multiply and divide. So count your sig figs. That's how many numbers should be in your answer. Adding, subtracting is a little bit weirder, but we really don't do that in this unit. And remember, whatever number I give you, that's going to be the one you want to look at for figuring out how many should be in your answer. So let's just talk about a little something. You're going to pick up two handouts. One, you're going to pick up some notes, and two, you're going to pick up a worksheet. Go ahead and take a look at those notes. I'm not going to go through the whole thing. I just want to talk about one thing with you. In common everyday language, we often refer to 12 things as being 1 dozen. And those 12 things can be anything. It could be 12 elephants. It could be 12 roses, 12 donuts, 12 ticks. I mean, it doesn't matter. 12 is a dozen. Half a dozen would be 6. And you can actually write that as a conversion. You can either put dozen on top or bottom, it doesn't matter. Well, in chemistry, we deal with atoms, and they are so incredibly small that we're not watching in a reaction one atom or one molecule reacting. We're watching gazillions. And so to deal with that, Avogadro came up with a number. And I don't remember how he did this. You can research it. But one mole, that's an M, is 6.022 times 10 to the 23rd, whatever, okay? It could be one, and by the way, we abbreviate it like that. Don't ask me why, but we do. This could be atoms, molecules, something we call formula units, like NaCl. One of them would be a formula unit. Please do not abbreviate formula units like this, because that, well, just doesn't look quite appropriate. And it could be anything. It could be representative particles, ions. So when we're doing these conversions, you're going to have 3 terms you're going to hear. You're going to hear grams, you're going to hear moles, and you're going to hear some other word. Again, atoms, molecules, formula units, representative particle, ions, something. So if you hear grams, grams. Mole, mole. The other word is going to be Avogadro's number. All right, make it a little bit easier. Now I want to go over a little something else with you before we dive into the worksheet. So make sure you have that worksheet ready. And while I'm just babbling on here, would you get your periodic tables out? You're going to need those. You guys should know that in math, if A equals B and B equals C, then A equals C. And it's the same thing with these 3 conversions. If you know the number of grams of some substance and that you have 1 mole of them, and 1 mole means you have this many atoms, then doesn't that many grams equal that many particles? Yes, it does. And so you'll notice on one of your slides that I have this figure that shows 6.022 times 10 to the 23rd. And I'm going to put atoms in quotes because, again, that number could be something else. And then we have a number of grams, and we have 1 mole. And the cool thing is you can bounce back and forth between any of these. Now, I say this because your book often likes you to go from grams to moles and then moles to atoms and vice versa, but you don't have to, because as I just showed you, you can go directly there. All right, kind of cool. And by the way, a little vocabulary thing for you. If you go look up a mass of an atom, like oxygen is 15.999. The proper label for this is grams per mole. And we call this the molar mass. Now, molar is not referring to your teeth. It is referring to having 1 mole. So anytime you look at any mass on the periodic table, you are assuming that you have a mole of that substance. So technically, the label is grams per mole. And a lot of times we just write grams, we get lazy, but this is a great conversion tool for later on. All right, that's kind of the preliminary stuff. Let's go take a look at your worksheet. I want to do number 1 with you. And I'm going to write kind of all over my screen because as you can see, I don't have a lot of room to write. Now, most of you are going to see the words and kind of freak out. I don't know where this comes from in life, but we see word problems and we flip out. Well, I'm going to be honest with you. I don't usually read. Do I need to know that chromium is a transition element that's used in chrome plating? No, I do not. So I'm just going to skim along and be like, hey, there's the number I was given. And you guys know, write down what you were given, dot line. So go ahead and write that down. And I am going to write CR because that helps me know what element I'm dealing with, and that is important. And I haven't even read anything else. I just know I have moles, and I know it's a conversion, so I know moles has to go away. So we're going to put it on the bottom. Now go back and skim. What is it you're being asked to find? Mass in grams. So I know grams is going to go up here. As I said earlier, anytime you have mole for right now. Now there is something we're going to learn in the next unit in January. And this isn't going to be true, but I'll explain that then. For now, mole gets the number 1 every single time. Mole gets 1. And that's the only thing that gets 1. Mole. Grams comes from the periodic table. So if you look up the periodic table, chromium has a mass of 5.1996. Okay? And you should see that moles cross off, and I'm left with grams, which is what I want. So mathematically, you're going to take 0.0450, multiply it by 51.996, and just to slow down, I'll do this on my calculator. And you get, because I want to show you the whole number you get, okay? You get 2.33982. Your number of sig figs are always going to go back to what you started with. I know this one was kind of mean. These zeros do not count. They are not trapped. They are not after the decimal and at the end. You know you count 4. You know you count 5. Yes, you count that 0. It is after the decimal and at the end. So we have 3 sig figs. So come up to your answer. Start with the first number. 1, 2, 3. We're going to stop the number right there. Always look to see if you need to round. Some of you messed up rounding on the test. Yep, this is going to become 2.34 grams, and there's your answer. Okay? While I erase, we're going to get ready to do number 4. See if I can erase. I don't use this program too often, you guys, and sometimes I just forget how to do things. So we'll see if we can get this all erased. But this is like taking me back to my younger days when we had to use those really horrible erasers on the chalkboards, and they never erased very well. All right, let's go do number 4. The reason I want to do number 4 is I didn't start you with moles. I started you with something else. So again, go skim. What did you start with? Write it down. CO is cobalt, dot line. I know grams of cobalt has to go down here. And go back and ask yourself, what are you looking for? Oh, moles. Write that up here. Now you need to fill in your conversion. What are you going to write with mole? Every single time. That's right. 1. Y'all, I know I don't want to see 1 anywhere else. The only time you might come close to writing 1 is if you're doing the mass of hydrogen. No other time should I see 1. Avogadro's number is not 1. Grams is not going to be 1. Okay? Go look up the mass of cobalt, 58.993. Or sorry, 933. I don't know why I keep thinking it's 993. And you'll notice your grams cross off and you're left with moles. And of course, by now, you guys should see this as a division problem. So grab your calculators. 2.03. I think most of you know the EE button. Most of you did very well on that. Hit EE4 divided by 58.933. And you get 344.458, blah, 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 right? Let's talk sig figs. Now, some of you got confused on sig figs and scientific notation on the test. You all ignore this. That never, ever comes into count with your sig figs. Some of you are trying to count the 1, the 0, and the 4. Do not do that. Here's the cool thing about scientific notation. Anytime you have scientific notation, ignore this and count everything that's in front of that X. They all count. So you have 3 sig figs and your number right there, and we get 344 moles. And just for learning, because some of you struggled on this, okay, let's say that we had to stop our number right there. Let's just say, okay? Obviously, the 4 is not going to round it up, so that is going to stay. Some of you are trying to round 344.4 to 34. Can you round 344 to 34? No, you cannot. So please make sure to remember that needs to be 340. Just a little lesson on the last test that we had. All right, let me see if I can erase again. I do struggle with erasing on this. This is a really cool program called Notability. The free version's okay, but you only get so much out of it. It's kind of like ChatGPT. After a while, you have to pay for it. Totally worth it. I know my son used this a lot when he was in college on his iPad, something you guys might want to think about. All right, let's go to number 6. In number 6, we're going to do a little bit of a different conversion. So let's go ahead and find what we're starting with right there. And notice, you guys, I gave you notes embedded in all the worksheets. Every worksheet in this unit, there are notes embedded in the worksheets. So let's write down what we have. We have 3 moles of K. 3 moles of K. Dot line. I know mole has to go down there. And notice, I'm not writing my numbers in my conversion until after I know where I'm going. I feel like if you stop and start writing numbers down, it messes up your brain's ability to think through. And guys, there's no memorizing here. It is critical thinking. You have to think about what you have and where you're going at all times. Notice it wants atoms. All right. Atoms. Well, we know the only thing that mole gets is a 1. Cool. I'm not dealing with grams. I don't need the periodic table. For atoms, I'm going to use Avogadro's number. Now, the only tricky thing about doing this is you have to use your EE button, and you have to start getting in the habit of looking at your calculator for that little tiny number. So, excuse me, what do I mean by that? 3 times, excuse me, I'm trying to have the hiccups here. 3 times 6.022 EE 23. Hit equals. And on your calculator, you're going to see this. And then up to the side, you're going to see that little tiny number right there. You have got to get in the habit of looking for that little number, okay? I often have a lot of kids telling me the answer is 1.8. No, make sure you look at that. And I know some of you use a different calculator than I do, and they don't do scientific notation correctly. I really advise you to use my calculators. My calculators are easy and you will get the right answer. So if you're checking answers and you're getting some crazy number up here like 47, it's your calculator or you're not using the EE button correctly, okay? And you need to ask me or somebody else who knows how to use the calculator for help. So anyway, you get 1.8066 times 10 to the 24th. Okay, you all, times 10 to the 24th. It's not a dot. It's not 1.8066 to the 24th. Those are very different things. Okay, do not do that. Anyway, how many sig figs? 1. So I'm going to stop my number right here. What does the 8 do to the 1? It makes it a 2. Please do not drop the rest of your scientific notation, okay? And then our label would be atoms. Now, starting on this next test, I do often require you to show work. There's a point for work, there's a point for the answer, there's a point for the label, and there's a point for the sig figs, okay? Oh, and for the record, I know this assignment is not for a grade, but from here on out, if you do not show your work the way I want you to, it's a 0. You have to show your work my way. Now, this isn't very difficult. We're doing some very basic conversions in this unit, but in the next unit, we're going to do a little bit more complicated. It's really not hard. Most people pick it up very easily. We're going to add one new piece to our conversions. And if you don't set it up the way I do, you're probably going to get it wrong. So please learn to do it my way. I know some of you don't like my way. Maybe it doesn't make a whole lot of sense, but I promise you, if you use it, it will make sense. So anyway, your answer for number 6 is 2 times 10 to the 24th atoms. So let me go in and erase everything, okay? See if I can get it all to erase. Yay. Let's go and do number 8 now, okay? Number 8. Again, skim. What did I give you? Let's write that down. 55.2 grams of Li. Dot line. No idea where I'm going, but I know I'm getting rid of that. Go back and read. Oh, it asks for atoms again. All right. Now fill in your numbers. Grams, periodic table. Do not give me a 1. That is for moles. Grams of lithium. And if you go to the periodic table, it is 6.941. If you can't find it, it's number 3. Atoms is 6.02 times 10 to the 23rd. And so beautifully, grams cross off, you're left with atoms. Now, this is a little bit uglier math. How do you do this on the calculator? All right, everybody grab your calculator. You're first going to multiply 55.2 times 6.022 EE 23rd. You better press equals before you hit divide. Otherwise, you only divide into Avogadro's number. Now press divides 6.941 and you get 4.78914 yada 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 times 10 to the 24th. Okay? Go back to the beginning. How many sig figs? 3. So you're going to stop your number right there. 4.7. What does the 9 do? Raises that to a 9 times 10 to the 24th atoms. Okay? Give you a moment to catch up while I erase. We're going to do number 11 next. Dang it. It's a very particular program. If you accidentally click on something else, it goes back to writing. All right, let's go on and do number 11. Right here, number 11. Again, what did I give you? Write it down. 6.02 times 10 to the 24th atoms. And y'all, I'm serious. You have got to write your labels. I know it takes time. I know you might get a hand cramp, but it is so worth it. All right, I know I'm getting rid of atoms. I'm just going to write it down there. Now I'm going to go back and think, okay, I need to go to grams. Perfect. What number do I always put with atoms? 6.022 times 10 to the 23rd. What am I going to write with grams? Well, bismuth molar mass. Bismuth is number 83. It is in column 15 if you can't find it, and it's 208.98. And again, you should notice that atoms cross off and we're left with grams, which is what we want. That's awesome. Now, the math is a little bit ugly here. You're going to do this times this, and I'm going to do it on my calculator so I don't go too terribly fast. 6.02 EE24, believe it or not, that's a 4, times 208.98, press equals, press divide, 6.022 EE 23rd equals, and you get 2089.105 yada yada yada, right? Grams. I'm gonna tease Tegan here for a moment. She was working on this the other day because she's gone for student council, and she got basically the same number, but she had like times 10 to the 47th. And that was a calculator issue. She was using a different calculator, and I know you can do scientific notation on it, but it's really particular and really hard to figure out. And once she used my calculator, she got the proper answer. So I'm just warning you, if you get some crazy answers, it's probably the calculator, or you're not using the EE button on my calculators. So let's go back. How many sig figs? 3. So I am going to stop my number right here. 2, 0. What does the 9 do? Raises that up. What happens to the 9? It becomes 0. You cannot round 2,089 to 209. If you bought a car for $2,089 and you told me that you rounded it to 209, that is not the same thing. Pretty sure you did not buy a car for $209. And if you did, good luck. Now, is this 3 sig figs? Yes, it is. This 0 is trapped. That 0 is at the end, but it's not after the decimal. I didn't put a decimal point there. If I put a decimal point, now it's 4. And if you're not sure, you can write 2.09 times 10 to the third and be guaranteed that you have 3 sig figs. Either one's correct. Please make sure you label your answer. I am very particular about that. Why am I so particular about labels? Because we have, believe it or not, writing and reading standards that go with science, social studies, etc. And they specifically say that you need to have clarity in writing. Labels are important. So you have 2,090 what? Grams? Boogers? Cars? Fleas? Dirty diapers? What? So be specific, okay? The last one I want to do with you is one of the ones from down in this last section. Now, guys, it's the exact same thing that we've been doing. The only trick here now is that you're not finding the mass of one thing. You have to find the molar mass of some ugly formula, okay? How do you find the mass of this? And I do it all at one time on my calculator, okay? Well, notice you have carbon. Carbon has a mass of 12.011. How many carbons are in this formula? 3 times 2 is 6. Then you have H. H's mass is 1.0079. Oh, by the way, you'll get these memorized just out of using them. And you have 10 of those. And I have 1 sulfur, and its mass is usually 32.06. Some periodic tables go farther than that. I usually just use that one. So by the way, if our numbers are ever so slightly off, mine versus yours, it's probably the periodic table we used, and that's okay. I'm very gracious on this. If you're within about 1/100th or 1,000th of my answer, do not panic. You're good to go. So on your calculator, take 12.011 times 6, hit the plus sign. 1.0079 times 10, hit the plus sign. 32.06, press equals. That is your molar mass for that hideous compound. And that is the only difference in these problems, is that you now have to go find the mass of an ugly formula. But that's what we do from here on out. Okay, guys? So let's just go back through what I told you to do. Write down what you were given. 2.50 moles of that long formula. And I would normally write that formula, but I will run out of room on my iPad, okay? And moles. And notice it says, what is the mass? So we're going to go to grams. Mole gets 1. Mass is going to be whatever the molar mass is that you got, and I've already done it. I got this for the molar mass, okay? Again, if this number is ever so slightly different, you're fine. Don't panic. Notice that moles cross off, and we're going to be left with grams. So when you do 2.50 times 114.05 on the calculator, you get, and I'm going to do that just so I have the whole number, you get 285.125. Go back and count sig figs. That is 3. This 0 is after the decimal, and at the end, it counts. So I'm going to go 1, 2, I'm going to stop my number right there. 2, 8, what does the 1 do to the 5? Nothing. 285 grams. And that is how you do the rest of this worksheet. It's really not that bad, okay? I promise you. The worst part is having to find the molar masses. And I just want to kind of show you something on that. So like this one, calcium hydroxide, you have 1 calcium, 2 oxygens, 2 hydrogens. Silver nitrate, 1 silver, 1 nitrogen, 3 oxygens. This one's pretty easy, 1 of each. 1 K, 1 Mn, 4 Os. 1 Al, 3 chlorines, 1 carbon, 2 oxygens, 1 Na, 1 Cl. So just pay attention to your subscripts so you don't get that messed up. That is kind of a trick to doing the molar masses. But I always like to double check myself. So when I was preparing to do this video, I found the molar mass of this one, and then I went back and just did a rough version. What do I mean by that? I know carbon is roughly 12, and there are 6 of them, so that's 72. I know hydrogen is roughly 1, and there's 10, so that's 10. And I know sulfur is about 32. I just do a very rough account, and then I add it up for 11. And so I know that my molar mass I calculated is correct because it should be about 114. Sometimes you're going to get really hideous, I mean, ugly formulas. And it's always nice to go and just double check that you're in the right ballpark. So when you come up and you check your answers, I want you looking at lots of things. Sig figs, labels, the times 10, do you have the correct exponent? That's a big deal. Even if you're just one off, it's a calculator issue. You are not doing something correct. Ask me, ask a para, ask somebody who understands how to do this. Other things I'm looking for your work. Did you write down what you were given? Dot line. Do you have labels? Guys, I cannot help you. I can't help you on a test if you don't show me labels. All right. So yeah, I'm being kind of particular, but I know where we're going and I know what you need to be able to do. All you're doing on this assignment is simply practicing these 3 conversions, going from grams to moles to atoms or whatever the heck that word might be, okay? And then we're going to see the application in this. There's so many cool applications of these conversions, and we use these conversions for the rest of the year. They really do get easy, I promise you. And I know some of you are probably not happy with me. Maybe you blame me for you're not doing well on the test. But I hope you can reflect on your own learning. I can talk till I'm blue in the face, but unless you do the practice, you are not going to learn. I need you to do the practice. And I'm going to drag you in every single Friday until you can do the last unit and you can do this unit. You want to know why? Because this is what I call one of my Mount Rushmores. Mr. Miller calls the standards that you absolutely, positively have to do. And even though chemistry, our standards don't totally line up with the state standards because they're more advanced than the state standards, this is a Mount Rushmore in my room. You have got to be able to do sig figs, multiply, divide, and do basic conversions. You have to. And I'm going to work with you until you get it. I will find a way to help you. All right? I'm here for you. I want you to learn. But right now, I want you to go finish the rest of this worksheet. It is not for a grade, but it's the basis of everything else we're going to do in this class, okay? Thank you guys for being such great participants. I will see you tomorrow.